Welcome back. In this lesson, we continue on with input devices and why they're required, and we're going to focus on two-dimensional and three-dimensional scanners. Let's start with 2D scanners. 2D scanners perform the task of turning a 2D document, which is basically on paper or perhaps an image like a photograph, into a digital file. They come in two varieties, flatbed or handheld. Some printers also have inbuilt flatbed scanners. Now, flatbed scanners basically means you have to put the paper flat on a glass surface and they will scan that paper. A handheld scanner means you will need to physically scan and move your hand with the scanner over a piece of paper. Typical applications for 2D scanners include converting a hard copy of a document into an electronic or digital form for storage, sending, or editing. They're also used for reading passports at airports and for other essential documents like boarding tickets. The benefits of 2D scanners include that they can produce a high quality digital copy of a paper document, and these digital copies of the documents can be sent electronically or stored securely, or perhaps even further edited on a computer. Drawbacks perhaps include that the scanned documents use a lot of computer stored space because you're converting it into an image, and image files take more space than text files. The bit you need to know for the exam is how a 2D scanner actually operates. The flowchart on the right hand side of the screen illustrates that. The process is pretty simple. A bright light illuminates any document or image. Modern scanners use a xenon lamp or LED to produce a very bright light. A scan head then moves across the document until the whole page has been scanned. An image of this document is produced, which is then sent to a lens using a series of mirrors. The lenses focus on the document's image. Now, this focused image falls on a charged coupled device, a CCD, just like a digital camera, which converts light into electrical current. If you've forgotten about this, essentially the CCD is made up of thousands of light-sensitive elements or pixels. Each element creates an electrical charge. This means that the scanned image is now turned into an electronic form, and then software produces a digital image from that electronic form. So the functionality of 2D scanners is enhanced when combined with optical mark recognition or optical character recognition software. Computers equipped with OCR software allows the scanned text from a document to be converted into an actual text file format so you can edit it. This means that the scanned image can now be edited and manipulated by importing it into a word processor, for example. If the original document was a photograph or an image, then the scanned image forms an image file such as JPEG or PNG. Now, in the exam, the most common form of application that you'll need to talk about is how they're used to read passports. 2D scanners make use of OCR technology to produce digital images which represent the passport's pages, especially the identity page. OCR software is able to review these images, select the text part, and then automatically put the text into the correct fields, for example, of an existing database. This is how your name can be checked. At many airports, the 2D photograph in the passport is scanned and stored as a JPEG image. The passenger's face is also photographed using a separate digital camera. The two digital images are compared using face recognition and detection software. And the key parts of the face that are compared include the distance between the eyes, the width of the nose, the shape of the cheekbones, the length of the jawline, the shape of the eyebrows. So when the image from a passport and the image taken by the camera are compared, these key positions on the face determine whether or not the two images represent the same face. Okay, that's enough about 2D scanners. Let's look at 3D scanners now. A 3D scanner is an input device that creates a 3D model of the object that's being scanned. Scanning can be achieved either by using lasers, light, radio waves, or even X-rays. Typical applications for 3D scanners include security screenings at airports to check for weapons or restricted objects, creating a computer model ready for 3D printing, biometric devices, turning real people into animated or gaming characters is another form of 3D scanning that's quite popular these days. Benefits of 3D scanners: the technology can scan through clothing and other materials. 3D scanning provides accurate 3D computer models. The major drawback of a 3D scanner involves those that use X-rays because repeated exposure to X-rays can be harmful. So you've got to be very careful in how much radiation you expose people to. What you need to know for the exam is how a 3D scanner actually works. 3D scanners can scan solid objects and produce a three-dimensional image. And since solid objects have X, Y, and Z coordinates, these scanners take images at several points along these three coordinates. A digital image which represents the solid object is then formed. The scanned images can be used in computer-aided design or CAD software, or more recently, they can automatically be sent to a 3D printer to produce a working model of the scanned image itself. There are numerous technologies used in 3D scanners: lasers, magnetic resonance, white light, and so on. Typically, 3D scanning works in the same way. So take a look at the image on screen. You normally have a light source or an X-ray source which scans through a solid object. The solid object now can be shown as a series of slices. Each slice is stored as a digital image in the computer. So you can basically see layers of the image being created. A quite common example of 3D scanning is computerized tomographic scanner, CT scanners, which are used in the hospital. CT scanners are used to create a 3D image of a solid object. This is based on tomography technology, which basically builds up an image of the solid object through a series of very thin slices. Each of the 2D slices make up a representation of the 3D solid object. Now, generally, 3D scanning works exactly the same way. Each slice is built up using one of the following technologies: X-rays, light, radio frequency, or even gamma imaging. It is then stored as a digital image in the computer's memory. On screen, you see a few common examples of technologies used for 3D scanning, mostly in the hospital. Chances are that these words might come across, though you are not expected to know how these technologies work. All you need to know about 3D scanners is that you use a source like an X-ray or a light source, capture the XYZ coordinates as images, and each image is stored as a slice. These slices are put together into a CAD file, and this CAD file contains the entire 3D model, which can be printed, or you can use it for whatever purpose you need to. Okay, that's all about 2D and 3D scanners. Hopefully you should be able to answer the following questions. You should be able to give one use of a 2D and a 3D scanner. You should be able to explain how a 2D scanner operates. You should be able to also explain how a 3D scanner operates. You should be able to explain what is meant by a slice or a layer. And you should be able to explain how a 2D scanner can be used to recognize a face, or used in passport control or ticket control, or automatically enter data into a text field on a web form, things like that. If you have any questions, as usual, get back to me. Otherwise, I'll see you in the next one.